Multithreading in Python. A comprehensive tutorial introduction to multithreading. Multithreading is a programming technique that allows concurrent execution of two or more threads, lightweight processes to maximize queue utilization. In Python, multithreading can be particularly useful for I/O-bound tasks, such as network operations or file where the program can perform other tasks while waiting for the I/O operations to complete. Why use multithreading? Concurrency threads can run concurrently, making programs faster and more responsive. Resource-sharing threads share the same memory space, which makes it easier to share data between threads. Simplicity. Multithreading can simplify program structure when tasks can be performed simultaneously. Python's threading module. Python provides the threading module for creating and managing threads. Here are some key components. Thread represents a single thread of execution within a program. Lock, a synchronization primitive that is used to ensure that only one thread can access a shared resource at a time. Event, a simple way to communicate between threads, allowing only thread to signal one or more other threads to proceed. Basic example of multithreading. Let's create a simple example where we simulate two tasks running concurrently using threads. Step 1. Import the threading module. Python import threading import time. Step 2. Define the tasks. Python def task name. Delay printf task name starting. Step 3. Create threads. Python creating thread instances. Thread on threading. Thread target task. argza. To thread to threading. Thread target task. argza. 3. Step 4. Start the threads. Python thread on start thread to start. Step 5. Wait for threads to complete. Python thread on join thread to join. Print both tasks completed. Full code example. Putting it all together. Here's the complete code. Python import threading import time def task name. Delay printf task name starting. Creating thread instances. Thread on threading. Thread target task. argza. To thread to threading. Thread target task. argza. 3. Starting the threads. Thread on start thread to start. Waiting for threads to complete. To thread on join thread to join. Print both tasks completed. Explanation of the code. 1. Defining the task. We define a simple function task that takes a name and a delay. It simulates a task of sleeping for the given delay. Creating threads. We create two threads, thread on and thread to, targeting the task function with different arguments. Starting threads. We call start on each thread to begin their execution. Joining threads. We use join to wait for both threads to finish before printing the completion message. Thread safety and synchronization. When multiple threads access shared resources, it can lead to race conditions. To avoid this, Python provides synchronization primitives like lock. Example of using lock. Python import threading import time shared resource counter 0 lock threading. Lock def increment global counter 4 in range 100,000 with lock counter 1 creating multiple threads 4 in range 5 thread threading. Thread target increment threads. Append thread start waiting for all threads to complete for thread in threads thread join printf. Final counter value counter. Explanation of lock. Example 1. Shared resource. We have a global variable counter. Lock. We create a lock instance to manage access to the counter. Increment function. The increment function increments the counter 100,000 times, but it ensures that only one thread can access the counter at a time using with lock. Creating threads. We create and start 5 threads that run the increment function. Joining threads. We wait for all threads to finish and then print the final value of the counter. Conclusion. Multithreading is a powerful tool in Python for handling concurrent tasks. While it can greatly improve the performance of I/O-bound applications, care must be taken to manage shared resources properly using synchronization techniques like locks. Understanding when to use multithreading will enhance your ability to write efficient and responsive Python applications. Further reading. Python's Threading documentation hut. Docs Python org 3 library threading idle concurrency in Python hats real Python Python concurrency threading multiprocessing in Python hats real Python Python concurrency threading zero multiprocessing. Now you have a solid understanding of multithreading in Python. Happy coding!